Welcome to Pomodoro Joe for Wednesday, June 21st, 2023. Today we're doing LeetCode problem 2448, minimum cost to make array equal. This is a hard problem. You are given two zero-indexed arrays, nums and cost, consisting each of n positive integers. You can do the following operation any number of times. You can increase or decrease any element of the array nums by 1. The cost of doing one operation on the ith element is cost index I. Return the minimum total cost such that all the elements of the array nums become equal. All right, so this is tricky. We're given an array of elements and an array of costs. So we have these elements that are associated with a cost, but they're not necessarily strongly associated, they're just associated by index. So our goal is to make all of these elements the same in nums at the minimal cost. Okay, so in this example, we have 1, 3, 5, and 2, and it's going to cost 2 to move 1 by 1 value. It'll cost 3 to move the element 3 to change element 3 by 1. It'll cost 1 to change element 5 by 1 up or down, and it'll cost 14 to change element 2 by 1 up or down. All right, so we have some constraints. Let's put 25 minutes on the Pomodoro timer and we will get started. All right, so for this one, I admit I did some prep ahead of time because this is a tricky problem and there are a lot of different ways to do this. I solved this in at least 3 different ways. I kind of like the way I'm about to show you the best. So this will be a little bit more logic and a little less code, but hopefully it will make sense. All right, so we will start with some result. We can set it to infinite to start with because we want to choose the minimum value, so we'll be constantly looking for something lower than our result, and then we will return our result at the end. Now in the solution I'm about to show you, I actually won't be using these, but I like to put them in here just as placeholders to know that we have some result. Okay, so in order to explain the solution, I think I need to explain a little bit more about these numbers and how we're going to group them. So when we initially have these numbers, we have 1, 3, 5, and 2, and their cost 2, 3, 1, and 14. I would like to associate these together a little bit more closely. So one thing I'll do is create a dictionary that has the value as its key and the cost as its value. So that way I can just look up the cost for any value. And the reason I want to do that is because we will be grouping our values together. And to explain that, I'll have to do a little bit of diagramming here, so bear with me. So in the example, we have values 1, 3, 5, and 2. So that's 1, 3, 5, and 2. So these are not in sorted order. That's okay. If we chose some value, let's say we are choosing 5, and we want to make all of our values equal to 5, there are certain operations we'll need to perform. So one thing, we'll have to take 1 and convert that to a 5. And so in doing that, we need to add 4, or take 4 steps with our 1, 4 operations. So the cost for this will be 5 minus 1. So that's how much do we need to change 1 to get to 5. So that's 5 minus 1 times the cost of changing 1. So that's our operation cost for this 1, which will be, and looking over here, that costs 2. So that's going to be 2. So the total cost for moving this 1 to 5 is going to be 2 times 4, which is 8. Next, we need to look at the next value. We're trying to make 3 equal to 5. So we take 3, we need to make it equal to 5. Now its cost is also going to be the difference, so 5 minus 3. So how many things do we have to do to 3? How many operations do we have to perform on 3 to make it equal to 5? Well, that's going to be 5 minus 3 operations, which is 2. And then we have to multiply that by our cost here. So our cost of moving 3 is 3. So our total cost for moving 3 to 5 will be 2 times 3, which is 6. And finally, well, I guess not finally, we do have to move 5 to 5, but that one is just going to be a cost of 0. So 5 minus 5 times whatever the 5 cost is. Let me move this down. Let's see, the 5 cost is 1. That's just going to be 0. And finally, we need to make 2 equal to 5. So 2 getting to 5. So that cost So this will be 5 minus 2, and then times the 2's cost, which is high, it's 14. So for that one, it's going to cost us 3 times 14, which I think is 42. So this will be our total cost. So let's actually calculate the total here. So the total cost will be 8 plus 6 plus 42. Well, 8 plus 42 is 50, so our total cost is 56. That's if we do these in the order they're given to us. Now, what if we did this a different way? What if we sorted these and then grouped them as we go? It's kind of like collapsing numbers into groups as we move from low to high. So if we sorted these and we had 1, 2, 3, 5, well, then we could do something similar, but we'll start at 1. And instead of taking 1 to 5, we'll say, how much does it cost to get from 1 to 2? So to get from 1 to 2, that cost will just be 2 minus 1. We're just moving it by 1 value, times the cost to move this 1 to 2, and that cost is going to be 2. And so this total cost is 2. So now we moved our 1 to be our 2. So now we have sort of 2 groups of 2, but we can actually just think of it as the number 2 now has more cost to move the entire 2. How do I describe this? Well, let's see. Well, we moved our 1. Our 1 becomes 2, and we paid an upfront cost to do that of 2. Now we have 2's that we need to move to 3. So now we have 2 to 3. Now this cost, again, will be 3 minus 2. But instead of just paying the cost for our 2, which is 14, we'll be paying the cost for both our 2 and our 1, because we've grouped them together. So now we pay the cost for our 1, which is 2, and we pay the cost for the 2, which is 14. So then our total cost here, actually, let me try to get more space here. All right, so that's going to be 16 times 1. So that's going to cost us 16 because we've grouped our 2 and our 1 together. And we can do the same. We can keep grouping these together. So now we're going to move our 3 to our 3. Now that's not going to cost us anything. So we've grouped our 1 with our 2, and then we've grouped our 2's with our 3. So now we have sort of all these elements, 1, 2, and 3, all lumped together at 3 here. Now its cost is going to be nothing compared to what we had before. So 3 minus 3 times, but again, we're grouping our costs. So that's the cost for the 1, plus the cost for the 2, plus the cost for this 3. It's going to equal 0. And then finally to 5. We want to move our 3 to our 5. So its cost, let's see, well, we do need 5 minus 3. And we've grouped our 1, our 2, and our 3 together. So we do have this grouping, which is 2 plus 14 plus 3. Now that's going to be a much bigger number. Let's see. So that's going to be 2 times 19, which is 38. Okay. And then we move 5 to 5, which we don't need to calculate. So let's just do our total here. So in this case, our total will be 2 plus 38, which is 40, plus 16, which makes 56. So we come out with the same answer, but we were able to start grouping our numbers together in order to get that answer. Now this will be key when we get to our solution. So the idea will be, we'll be moving our lower numbers to our higher numbers, and as we reach our higher number, we will group them together, and that will actually group their costs together. So then we figure out how to minimize the cost. So let's start. So the first thing I want is my dictionary that maps our value to our cost. So this is going to be a num to cost mapping, or just map. That's going to be a default dictionary of integers. So the value will be the cost and the key will be the number. Okay. Now, for every num in our nums, we'll just add that cost. It looks like we're going to need we'll need our index to get our cost. So let's do that here. Actually, let's grab our n. So n will be the number of elements we have, so that's going to be the length of nums. All right, so for I in range n, our value, or our num, I should say, the num will be just nums at index I. And the cost, I can't use the word cost, that's annoying. It's going to be cost at index I. And so our key value pair will be this num to cost map. And we'll just take this value at num, and we will increase it by the num cost. Since I'm only using this num cost here, I'm just going to do this. All right. So now we've got a mapping between our number and the total cost it's going to cost us to move that number either left or right, higher or lower. Okay, now that we have our number mapping in place, we can sort our numbers without having to worry about losing the connection between our nums and our cost. So I'm going to have a sorted numbers, or yeah, I'll call it sorted numbers. That's going to be sorted, and again, we might have had duplicates in our input, so I just want to keep the originals, so the non-duplicated numbers. So that's just going to be the nums. That's going to be this nums to cost map keys. This way we only have our unique numbers. Okay, so hopefully this makes sense so far. We've got our mapping that will take our number and give us the cost to move that number either left or right by one value. Okay, so at this point we have our numbers. Now we could go through and just solve immediately for every single sorted number, figure out which one gives us the best result. So let's just write that out here. It's not going to be the right solution, but I just want to go through this because it helps us get to the right solution. So for every target number in our sorted nums, so if that is our target, we can calculate the cost to get to that target. And that cost will just be basically moving all of the other numbers to this target and summing their costs. Let's see. All right, now for every number in our sorted nums, we're trying to get to that target. And so we have a delta. How do we get to that target? Well, we need the absolute value. So we need the absolute value between this number and our target number. And then the cost for this number to get to our target number will be that delta times the cost in our dictionary in this nums to cost map. So the total cost here will increase by, let's see, nums to cost map. For this number times this delta. So the delta tells us how many spaces we need to move or how many values we need to move, and the cost tells us how much it costs per move. So this will give us the total cost of movement for this number to get to our target. Now I don't have this total cost, so I'll have to put that out here. Start at 0. So now once we've calculated the total cost, we can basically get our result. We can say, is the result better than this total cost? If it is, then we'll keep our current result. Otherwise, we'll take the total cost. I'll just do min for now. So the result will be the minimum of our result or this total cost. So hopefully this makes sense. We're just going through, we're choosing a target, then we're calculating what's the cost to get to that target. So all of our elements are that same target value. And if we find a better result, we'll keep that. Otherwise, we'll move on. And so we find the minimum result and we return that result. So this should work. Let's just see. I spelled sorted wrong. All right, try this. All right, now that I fixed that, let's see if that works. Okay, so this works. but I can already tell you it's going to take way too much time. We're calculating these costs over and over and over again, which is very expensive. So there is a better way. What if we don't need to calculate the costs for every single target value? That's kind of the key to this one. This is correct in terms of finding the cost for a target value, but we don't actually have to explore the cost for every single target value. You know what, let's submit this. Actually, let's do it. Let's submit this and see how we do. We know that it works, we just don't think it's going to run in the time that we need. All right, time limit exceeded. Now we do beat 37 out of 46 test cases, so we actually do okay. We have a decent algorithm, it's just not fast enough. So we'll use this test case and see if we can do better. So that's our brute force approach, check every single target number for the answer. Now what if we broke this down into a simple problem? We have two elements. We have A and B. So we just have two elements in our array. All right, so we know that they're unique and we know that one is greater than the other. By definition, they're unique and they are in the same number plane, so we have A and B. Now, is it better to move A toward B or B toward A, or move them both? Well, it kind of depends on how much they cost. So let's say that A costs more than B. So A is going to cost 5 and B is going to cost 2. Now which one do we move? Well, we know A costs 5 and B costs 2. There's no reason to move A when you can move B all the way to A and only pay the cost of 2, never having to pay the cost of 5. So at this point we have A and B. We always want to move the cheaper one. Now, does it make sense for them to meet in the middle? Maybe move A some and B some? Not really, because for every operation in A, you get closer to B, and for every operation in B, you get one closer to A. Either way, you're getting one closer together, but in one case, you're paying 5, in the other case, you're only paying 2. So you always want to move B toward A. Move the cheaper group toward the more expensive group. Now in this case, this is just two elements, but what if these weren't elements? What if these were groups of elements? So this is where our grouping discussion from the very beginning of this video comes in. If these are groups of elements, so let's say we have group A and group B. Now which one do you move? Well, it's kind of the same thing. If it's group A costs 5 to move one element or one value toward group B, and for group B, it costs 2 to move 1 toward group A, well, let's keep moving group B until we basically converge on some value in group A. So that's what we'll be doing here. We'll be going through groups and figuring out which group has the best solution. All right. So for this, we'll need a couple pieces. The first piece that we'll need is, I guess, the cost of moving each group. So we have our left group cost. And for that, we're going to start it at 0. So we're still going through every single sorted num here. So we're going to start at the beginning and we'll move through. But at the very beginning, you can say, how many elements are to the left of this element? Well, there are 0 elements. So the cost to move that group to our current element, well, there's 0 cost because there's nothing to move to the right. So this is kind of saying, how much does it cost to move all the elements in our left group one step to the right? And then we'll have our right group cost. Sort of the same thing, but in this case, because we're starting at our leftmost element, this is the cost of moving all of the elements from our array to the left. So that's going to be more expensive. In that case, I'm going to call this total cost, and you'll see why I call this total cost in a second. Essentially, we're saying how much is it going to cost to move all the elements in the right group? Now in our initial group, we have no elements in our left, every element is in our right. So it's the cost of every element. So our total cost, we'll actually calculate it here. That's just the sum of all the costs. So how much does it cost to move all of these elements? It's going to be the sum of all of their costs. Now in our left group, there are no elements in it, so it costs 0. In our right group, we have every element in it, so it's going to cost the total cost. Now this is not the total cost to converge on a particular value. This is just the cost to move that entire group by one step. Okay, so now that we have this, we've figured out we have our left group cost and our right group cost. when we go through our target values here, we can actually group our target values together. So initially our target num will just be the very first number. So the cost, let's see, I need to change some of my values here. So the cost of the left group here, so the left group cost, now we are including our target number in the left group. So our left group at this point is going to just be 1. And the cost to move that 1, left or right, it's just the cost to move it by 1 operation. So the cost to move our left group will be increased by the cost to move this new element that we're adding to our left group. So that is going to be this num to cost map value. So that's going to be the num to cost map for this target num. And now our right group cost. All right, so the right group cost. Well, we already know the total cost to move all the elements, and the right group is basically everything that's not in the left group. So we can just subtract the left group cost from the total cost. Okay, so now we have our left group cost and our right group cost. Now at this point we have to decide, do we want to move the left group 1 step to the right, or do we want to move the right group 1 step to the left? Now, just a caveat here, we are including the actual target number in the left group. So if we are moving the target number to the right, it means that we actually don't use that as our target, do we? So if the left group cost is less than the right group cost, we'll be moving the left group. As we discussed before with our group A and group B, we always want to move the cheapest group to move. So if the left group cost is less than the right group cost, then we definitely want to move the left group, which means that the target, which is in the left group, can't be the actual target number we're looking for because we'll be moving it. So in that case, if the left group cost is less than the right group cost, then we'll want to move our left group. And if we're moving our left group, we'll be moving it to the right. And if we're moving our left group to the right, and our left group actually contains this target number, that means that target number isn't really going to be our target number because we're moving it to the right. So in this case, we'll just continue. We already know that this target number is not the actual target number we're looking for. So we'll just move on. Now at some point, our right group cost will actually fall below our left group cost, which means at that point, it's cheaper to move the right group to the left. And the value that's at the top of our left group, well, that is our target num, and that is the value that we're looking for. Because every time we're moving our left group to the right, it means that it doesn't actually contain the target that we're looking for. But once we're moving our right group toward the left, we're moving it toward the target, which is in the left. And that target will always be the top of the left. So that's going to be our target value here, this target num. All right, so once we get to this point, we've gotten to the point where we've basically ignored all of these left groups where it's costing more to move the right group toward that target value than it is to move the target value toward the right group. Then we get to this point where we can actually say this is the target value we're looking for. And we need to calculate the cost of converging on that target value. So let's see, I called this total cost, but I have this total cost, so I'll have to rename this one to be, well, it's funny, we have something called result here, and we'll just set it equal to 0. And instead of calling this total cost, I'll call this result. And instead of taking a min, we've already converged on our result. We can just return our result. Okay, let's run this and see if we can pass. All right, this should be cost singular. Man, I am butchering this one today. Okay, so this does pass. Let's see if we can pass all of the tests. I'll submit this and see how we do. And we pass. And we do pretty well, actually. We do more than pretty well. We do great. What? We beat 98.57% for runtime and 38% for memory. So that is pretty darn good. Now this one is super tricky, I won't lie. I did this one a couple different ways. I built a matrix in one solution, didn't run in the time I needed. I did a prefix sum in another solution, didn't really run in the time that I wanted. Actually, that one did pass, but it didn't do great. This is the best solution I've found so far, and I did have to do some research on this. I did not come up with this on my own. I came up with a variation on my own. This is not the variation that I saw, but this is my own take on that variation. All right, I am out of time, so that is it for me. Check this one out, try it. It's really tough, but it's fun. I recommend, if you do try this, check out some of the solutions here. Like, these are some other solutions. I think the one I was looking at was like here. See how short that is? That's crazy short. It's a little bit different than my solution, but it's similar. So yeah, check these out. All right, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.